N?
End at 2 pi. Okay.
That's
0.314. 0.314. Yeah?
what's this big one? I didn't understand. The last thing.
How big the x's change, how much they change. Okay. Are you going to buy new calculators, or are you happy with those two things? Are you sticking with those? You've grown attached to them? You've had them since high school? Okay. They have sentimental value, yes? That's fine, that's fine. But as you can see, we've got more functions here. Yeah. Okay. Can we just lower the projector a little bit? Like, can we move it back? Or closer?
Down a little bit.
Okay, let's have a look at the graphs. So it's not too difficult today. We're just making the graphs. So before we start, with the help of our calculator, we can see that the sine, it goes up, then it goes back down, and then it goes back up again. So I don't understand this at all. There we go. So with the sine graph, you should draw this one. Here we go. Oh, and you do get this in the exam. So sine goes from 0 to 2 pi. That's pi. Pi over 2. 3 pi over 2.
Y, 1 and minus 1.
Very good. It goes up to 1, and it goes down to minus 1. So the graph goes up, down, up. Yeah, you know what I'm doing, like this. And some people have seen this graph before. They know that it increases, or not increases, repeats. So it keeps going like this, okay? So that is the graph for just a simple sine x. Now, I did this graph in radians. If you did it in degrees, then it's not 2 pi at the end. What would it be? 360. Either way, it's the same shape. Okay? So can you draw the sine x? And then we'll do cos and tan. And then more importantly, variations of it. Shunwei, I see you decided against 914.
What?
I see you decided on not 914.
Yeah.
Good call, good call. This is common on the exam. It's in about 50% of exams. Yeah. Okay, can we do cos now? Yeah? Does anybody know what shape the cos graph makes? Yeah.
Start from 1.
It starts from 1. It's upside down, nearly. Well, not upside down. It starts at the top and goes all the way down, passing through pi over 2. Yes, yeah, shifted, yeah. And then it goes up here, and then it will finish back at 1. So it actually looks like a big U shape here. And again, it repeats. If you want to draw that on a separate graph, that's a good idea, but you can draw it on the same graph if you're comfortable with that. Y equals cos x is in red. Oh, the colours aren't there. You don't, oh, you can't see the red and the blue. Hang on, hang on. Come on. No, no colour. Well, you should draw a different colour, it will help. Come on. Oh, oh. There we go. Hang on. I'll just hold it for a minute so you can see the different colours. So can you see the cos is in red and the sine is in black? Have you got that? Yeah? Okay, I have to let go now. I can't hold it for the class. Okay. What about the tan x? Does anybody know the shape of the tan x graph? Yeah, like this. So tan x, I'll put it on its own graph. Yes, it does. And here is pi over 2, and here is pi. Let me go a bit to the right. And here is 3 pi over 2, and then here is 2 pi. So with tan, and here is minus pi over 2, minus pi, etc. With tan, it goes from minus infinity, passes through the origin, and then shoots back up to infinity, and then repeats like this. So you get these stripes for the tan graph. And the distance between each stripe, how much is that? Pi. Yeah. So they keep repeating like this every pi distance. Yeah. This is the tan graph. They've never ever asked you to draw the tan graph. Well, just because it's weird. But I think they could, but it's usually the sine and the cos that they ask for. The basic ones they won't ask you for. Let's look at a difficult one now. And I think to help, we'll get some beautiful graphs. Okay, can I scroll down? Yeah. So what we're going to have a look at is how to draw graphs of this form. A sine B, another bracket, x, well, yeah, x plus c, close bracket, plus d. Or sometimes it can be written like this, a sine bx plus c plus d. Now, I know it doesn't look like there's much of a difference, but there's actually an important difference. What's the difference here?
They have constants.
Well, they all have constants.
The c is not being multiplied by b.
Yeah, the difference here is the b multiplies both of this, whereas here the b just multiplies the x. Yeah? Now, often this is how you will get it in the question.
And is the d outside? Or
It's outside in both, yeah. Often this is how the question is written, but you should write it in this form. It makes it easier to do. So, for example, if you get a question that has for example, 2x plus 4 here, then what do you need to take out? Take out the 2, and now it's written in this form. So my point is, you should always factorize it. So what I'm going to show you is for problems in this form. That's what I'm going to do now. Okay? Right. So the first one is looking at the A. Can I go down? No, not yet. Have some people seen this before?
Yes, but we forget it.
Yeah, okay. I can scroll down now? Is that yes? Yeah, okay. So the first thing is the A. So for example, if you have y, hang on, let's try that again. You have y equals a sine x. So does anybody know what the a does to the graph? If I stick an a in here, so I can actually, you can have a look at the graph. So if I stick an a in front, like 4 sine x.
Moving up or down?
Not that one. Yeah, it expands on the y-axis. So it'll be 4 times bigger on the y-axis. So if we look at the graph, it stretches.
Yeah,
That's what you meant. Oh yeah, no, that's okay. The vocabulary we need to learn too. So here we say it expands by a factor of a along the y. So this is our first one. Okay, the next one, y equals sine bx. So does anybody know the effect of the b? Yeah, so give me the verb that describes the change in the shape. You know the verb? So what happens to the graph? How would you describe it? Yeah, what verb? Give me a verb for this. Any verb. Any verb.
Squeeze it or
Squeeze, I like. Yeah, anything else?
contract.
Yeah, I like. Something else though. Squeeze, squish, smush. What else? Anything else? That's the one I'm looking for, yes. Compresses. You compress the graph on the x-axis. So for example, here, if I had sine 4x, so here's the original graph, and then here is the compressed graph. Compresses it 4 times, a factor of 4. So the next one here, compress along the x by a factor of b. Yep. Okay, so we can get the next one here as well. Y equals sine x plus c. Does anybody know this one?
Moving the x.
Yeah? How? X or y?
X.
Left or right?
independent, if it's minus or
Yeah.
Minus
Plus,
minus.
yeah, plus we move it to the right here. So if we were to look at the graph again, and if I did sine x plus 0.314, for example, and draw this again. So graph, oops, that one there. So you can see that the plus, the original was, I'll show you the original first. So you can see now when I add in this graph, it's a little to the right. Watch, it's a little to the right. Let's make it a little bit more to make it clearer. Sorry, I said right. I said right, and in my brain I was thinking left, but right came out. When it's plus, you move it to the left, and when it's negative, you move it to the right. It's actually the opposite of what you think it would be. So the plus c moves it to the left, and the minus c, a minus number, moves it to the right. So you need to be careful with that one. So the plus c here would move it to the left. So for this rule, I'm going to assume it's plus because I wrote a plus here. So here, we don't use the word move. We have another verb that means move. Does anyone know another verb that means move? Give me verbs that mean move. No? Shift. What else? Travel. Yeah. Commute. Go. What else? Relocate. Yeah. Reposition. Yeah. For a strange reason, we use this verb. It means move, but we don't say move. Yeah, translate also means, you know, for the language as well. So we translate C units to the left. Y equals sine x plus d. Okay. And the last one here? Well, no, there's another one to do.
translating the y-axis.
Which way? Up or down?
Up.
Correct. So you're right, this one here would translate d units up. So I'll draw that just so you can see it. So if I do sine x plus 4, you can see, there, it moves it up. Can you see? Yeah. Okay, there's still one more I haven't done, is if you have something like y equals minus sine x, or something like y equals sine of minus x. So if you put a minus in it. So what happens here if you put a minus in front? Does anyone know? Yeah, flips upside down. So it goes upside down. Like watch here. So if I go minus sine x, it flips the graph upside down. And what about this one here?
It's a disk.
What do you think?
Is the y-axis is it plus?
Yeah, it flips it around like this. So the first one flips it like this. The second one flips it around. So it literally, it's like you spin it around. Yeah? No. Yeah? Flips around the y. So if we imagine the y-axis like a pole or a door or something, it flips around it. Yeah. Let me show you with an example here. So if I had sine x, now before I draw it, I want you to try and picture it in your mind, what it looks like. So have a look at that graph, and then imagine it being flipped around.
It will start from 0 to minus 1.
Yeah, it should go down at the start. Could you flip it around?
Yeah.
So if we have a look now at it, yeah, if you flip it around. So in this case, it looks like the last one as well. Yeah. Okay, so now that we have all of that covered, we can look at some examples. Can I go down? Do you have this? Do you have this? Yeah. So let's say we have something like y equals 2 sine 4x plus 2 minus 1. And here I tell you no, I won't tell you the range. We'll just make a big graph. Okay, we got that? So what do I need to do first? What's my first step?
X and Y.
Say again?
X and Y. Like draw the
Well, even before that,
the what's the maximum and minimum?
yeah, factorize the 4. So I say y equals 2 sine 4 x plus half, close, close. So here we can write down the a equals 2, the b equals 4, the c equals a half, and the d equals minus 1. So far, okay? Yeah. Now, we make a table, but not like the table you have on the calculator. So what I'll write is start, end, min, max. One, two, three, four. I'll need 5 altogether. Okay. So we need a table here. You just make a table. I need to have 1, 2, 3, 4, 5 rows. Yeah. Okay. So what you do is, for the first row, you look at the sine. It's a sine graph. So for sine, just plain, boring, simple sine, it starts at 0, it ends at 2 pi, its lowest point is 1, and its highest point is 1, minus 1 and plus 1. So this is because it is a sine. So if it was just a sine graph, you would have this. True? If it was just sine, it would go up, down to 1, minus 1, 0 to 2 pi. Yeah? Now what we do is we look at the effect of each constant here. So now let's have a look at what the A does. So if I put in an A is 2, what happens to the graph?
Still 0.
It still starts at 0, and it still ends at 2 pi. But what's different now?
Minus 2 minus.
Very good. It goes from minus 2 to 2. Because it's expanded vertically. Now, let's look at the B. What is the effect of the B? It compresses. So it still starts at 0, but it doesn't finish at 2 pi. It finishes sooner than 2 pi. Where would it finish? Half pi. Because it's compressed 4 times on the x-axis. So it finishes 4 times sooner. Does the height change? No. So here we're still at minus 2 and 2. Okay, what is the effect of the C here?
Move it.
Left or right?
Left.
Left. So it no longer starts at 0. It now starts at, now you know what, I'll just make my life a little easier by calling that pi over 2. So you can just change that to pi over 2. So now it starts at minus pi over 2. And where will it finish? If I move it to the left, it'll finish at 0. And the height doesn't change. Finally, the D. Does the D affect where it starts?
Yes.
Does it?
Oh.
Not on the X.
Nothing.
Yeah, but it does change the height. So what does the D do here?
Move it.
Moves it down in this case. The D is minus 1. So it moves it down 1 unit. So the minimum point is now minus 3 and the maximum point is 1. This, yeah?
Why in the start at minus pi over 2?
The C here moves the graph to the left. So we move pi over 2 units to the left. So if we were starting at 0, we now start at minus pi over 2.
And then this maintained until, like, for the D?
This, oh yes. All changes are maintained in the next row. Yeah. So we're adding in one change at a time. Can I go down to the graph now? So the table, it will really help you make the graph now. Can I scroll down? Yeah. So when you're making the graph, you just care about the last row. Okay, so we make a nice big x-axis, nice big y-axis. The exam will tell you where to start and where to stop. But for me, I'll just go from minus 2 pi to 2 pi. So here is pi, minus 3 pi over 2, minus pi over 2, pi over 2, 3 pi over 2. By the way, if the question asked you to use degrees, what would these be? What would this one be at the end? And this one? 180, and this one?
90.
And this one? 270, good, okay. Right, and I'll go up to 4 here. A little extra won't kill anybody. Now, it'd be really nice if we had the colours here, but Okay, I really want the colours for this part, it'll help. I'll show you the colours, but I'll have to hold this. Okay. Right. Carefully now. So what you do first is you look at where it starts. Where does this start?
Minus pi over 2.
Minus pi over 2, which is here. So in light pencil, you draw a line going straight down through the minus pi over 2. That's not straight, but you know what a straight line looks like. Minus pi over 2. And where does it end? At 0.
Yeah, 0.
So you draw a straight line down through 0. Now, what's the lowest point? Minus 3. So you draw a horizontal line going through minus 3. And what's the highest point? 1. So we draw a horizontal line going through 1. So you see that I've made a box, a square, a rectangle? A rectangle, you see that? The next step is you take this rectangle and you split it up into exactly 4 equal quarters. That's 1, 2, 3, 4, so it'd be going across here. Now I know it's very messy for me because I don't have a pencil. So if you're doing this in the exam, you do all of this with a light pencil, and then the final graph is in a dark pencil. Now I'm ready to draw the graph. You look at this square, you see here, and you remember that it's sine. And when you think of a sine graph, does it go from the middle, the top? I mean, where does it start? From the middle, and then it goes up, and it goes down, and back to the middle. So you do the same thing in this box. You start here, and you go up, down, and then back up. If you need to make the graph bigger, what you do is you copy this box and make the same box, like an exact copy of the box, right beside it. Well, no, you have your ruler, you can, measure it and draw it. So, if you needed to continue the graph, you would copy and paste with your pencil. You know the old copy-paste function on your pencil? Yes, that old one. So we copy-paste, and then the graph would continue like this. Yeah, well, you get the idea. Okay, now I'll show you what the graph looks like nicely in my program. So when I look at this graph, what I should get is a very tight graph that's a little bit below the x-axis. Let's have a look at. Can you read back what the graph was? 2? Yeah.
4x
Plus 2. That was the original. Yeah. Minus 1. Okay. Oh no, wait, I changed it a little bit, sorry, yeah.
You add pi.
I added a pi, so that should be 2 pi now. Just change that to 2 pi. Okay. So let's have a look at this graph. Exactly like what I drew. Yeah. So can you see that? It's look, I challenge you to find a difference between the two. So you can see that I've got the basic idea that it's compressed and that it's below the it's more below the x-axis than it is above the x-axis. I mean, look, this graph cuts in here about at -1. Yeah. Now I know you're laughing at my graph, but that's exactly what I have here. It cuts in. If this is 2, then this point here is -1. So I know it's ugly looking, but it's exactly right. It's exactly the right graph. Now, of course, in the exam, unlike me, you will have nice ruler, you'll have graph paper, you can draw this very neatly, you'll have a light pencil if you want and a dark pencil, or what some students do is they use their pencil and then at the end they use a pen or a marker to draw the shape in, okay? Don't do this graph only using pen. That would be very messy. You need something light to make the box, and then you need something dark to draw in the curve. You know what I mean?
Yeah.
It's a common question in the exam. Like I said, it's about 50% of the time. Now you might say, okay, well what about cos and tan? Is that any different? And the answer is no. The only difference, if I was to change this to cos, what would be the only difference if I made this cos? Yeah, the shape of the graph at the end. When you make the box at the end, the only difference is it starts not from the middle but from the top and goes down and back up. This would be the only difference. And what about tan though?
Start from minus.
Where does tan start? The top, the middle, or the bottom? The middle, if you remember the graph, because the graph is like this at the start. So it starts at the middle and then shoots up to infinity. But then it comes back from minus infinity. So the graph looks really weird in the box. I think it's like this. So this is why I don't think they'll ask you the tan graph in the exam, because it's really difficult to do. And it's also not very interesting, because with the tan graph, what's the minimum point here? Minus infinity. And here it will be plus infinity. So if I add d, is that going to change it? No. You know. So I don't think they'll ask the tan. In fact, they've never asked the tan. And I'll need to double check the syllabus, but I'm 60% confident that it actually says on the syllabus for the exam it's only sine and cos. But at the very least, in the last 18 exams, it's always been sine or cos and it's never been tan. Okay, so I wouldn't worry about tan. I think I have some tan in here just for you to try. But if you have trouble with tan, don't worry about it. It's sine and cos that's most important for the exam. Yeah. Now, there's not many questions there, so I would like you to try all of them. But like I said, those tan questions, try them, but don't worry about them. And I have the graphs at the back as well, so you can compare.
We have
Yeah?
3 times.
Question? Oh yeah, by the way, all these graphs, they're in radians. They could be in degrees, but I notice in the exam, they prefer to ask you to do it in radians. Very unusual to have degrees. They much prefer radians in the exam. So that's why I did these in radians as well. Because degrees, everybody is familiar with. Radians, people, you know, a little bit newer. Okay, so try and have those finished. We have class tomorrow, don't we?
Yeah.
Yeah, but one of them's a tutorial. So we could practice some more of this and the equations from last time in the tutorial, okay? Alright.
We won't have a new class tomorrow.
I will have a new class, but I'm saying in the tutorial we'll probably do the equations and the graphs, because they're a little bit tricky. Yeah. I'd really love to know what you whisper about so much. Is it the same topic, or is it always something different? Okay. Is there anything that I would be interested in?
Do we have global
semester actually, and the next. This is good or bad news?
Yeah, back.
Bad news.
I prefer calculus than probability.
Me too. Me too.
Like sometimes confusing with the question.
Mhm.
You
Yeah.
might know how to answer it exactly, but to get the information from the question is better.
Oh yes, definitely,
Yeah.
definitely. I'm in this room next. You're not, right? Yeah.
We have Mark.
Yeah. I think you're downstairs. Is it?
Yeah.
Yeah. Okay. See you. Oh wait, hang on. Who was I missing? It was Ricky and Albert and Nina. Those three. And Marcelo. Those four. Just, I think. Okay. Marcelo. Yes. Okay. Try not to break your neck. You might need it for the maths exam, okay? See ya. See ya.